Hi everybody, my name is Dan Trout, and I am an employee at the Colorado State University METech site. For those of you who don't know, that stands for Methane Emissions Technology Evaluation Center. And briefly discuss my qualifications, I am an employee at the site, and I've been working with flow mechanics for about 3 years now in my undergrad at Colorado State University. The whole project here will be the feasibility of a high volume gas release system at the site. So first I'll jump into a little more about the site. So the reason we exist is because immediately, as soon as it's pumped out of the ground, 10% of all natural gas is immediately lost to the atmosphere. Methane and other natural gases are a major pollutant, and on top of that, billions of dollars are lost with this 10% loss every year. So the site is committed to improving this metric. Essentially, we want to help companies find these leaks, study them, fix them, and do all kinds of research to generally improve the industry. So with that, one of the things that they desire is a high volume flow system. So this high volume system, as you can see in this diagram up at the right, is essentially a system of tubing, shutoff valves, regulators, and this guy right here. These are mass flow controllers that are allowed to pump exactly the amount of gas that we want into the atmosphere so that companies can come back and we can tell them exactly how much we put out, and they can tell us where their data was to help them improve. So with that, the controlled release of this specific system will be 1,500 square liters per minute, which is a good amount to test from airplanes and satellites, which is what a lot of major companies want to do. So another requirement of this system is it needs to be mobile, because it's a safety thing. With that amount of gas, there's a lot of spark hazards on the site, and it would create an odor that might upset our neighbors, as it is all natural gas. So this site is really a necessity. We need the high volume system. It'll draw more companies to the site, and it'll increase the price of using the site so that we can have more income. So ExxonMobil, University of Colorado, Colorado School of Mines are all places that are willing to pump a lot of money into this exact thing because they want to be able to study high volume flow. So let's jump into feasibility and budget. It really just needs to meet 3 criteria. The proper parts to build this must exist, it needs to be mobile, and it has to be at or under budget. So with that, jump into budget. Our budget allowed was $30,000 from a $100,000 project grant from the Colorado State University Energy Institute. After creating the bill of materials, it turns out that the exact estimate for all the parts will end up being $11,846.55. With shipping, it'll round up to about $12,000 on that $30,000 budget. So, we come down to, is it feasible? All the parts do exist. I put them all into the bill of materials, and they can be assembled properly. It can be made mobile, as all these parts are small enough to fit on our site truck, and we can move it wherever we want. And it'll be under budget, as that $12,000 is significantly below that $30,000 limit. So, in conclusion, the project is feasible and it should be implemented at the site immediately. Thank you all for coming, and have a nice day.